In this video, I'm going to give a crash course into FM synthesis and a little bit of sound, like how to approach sound design with FM synthesis, particularly for chiptune. And this video is going to be sort of broken up into like three major parts. First, I'm going to go into how FM synthesis kind of works, and then I've got some sample instruments here that I'll just like go and sort of break it down. So that will build off of explanation in the first part, and then the third part is trying to build some FM instruments from scratch with what we've kind of gone through over the course of the video. And so I've got right here Furnace. It's a free chiptune tracker that you can just find. Very common nowadays. It's very nice. But particularly, I've got this set up with a YM2612. It's the sound chip used in the Sega Genesis, particularly. And we'll just get into it. So let's get a blank instrument here. And so, FM synthesis, it's built off of these ideas, off the idea of like having these operators. So an operator is basically just like it's a sine wave. You can set it's like frequency, and it'll just go. And what we have here is all of these are going to be kind of muted by default, but I'll kind of try to go over all these little parameters here as they come. So we've got TL, which is the level of the operator. So right now they're all set at 127, which means they're all basically muted. But if I take this op4, which is kind of the end, and I'll explain these in more detail later, but just starting off with op4, if I bring this up and then I just jam, you get this little sine wave here, right? And then you can like play different, or if I right? So that's what TL is. It's just the like how loud, so I can like put it half. It's actually like very weirdly curved. So like up here is like maybe halfway, and then like as it goes down, it's like super quiet. So yeah, you can kind of tune the volume. As you can see here, you can tune the volume of the operator. So that's kind of the first part. And then you have these, I guess, 5 things. So you have A, which is attack, D for decay, S sustain, there's a decay 2, and then release. And so this is what's commonly known as ADSR, or an envelope. And it's basically how you shape your the sound or the volume of the operator over time. So by default, it's like 31, 31. So these are at the bottom, these are at the top, and then this one's at the bottom. So what attack is basically the fade in. So and you can see kind of here on the envelope, it gives you a visual representation of the envelope. So if I have it like up here, you can see that it slowly fades in. D's decay. So that's basically once it reaches this top point here, okay. So sustain is, these two kind of go hand in hand, decay and sustain. So sustain here, you can see, is kind of what level the operator goes to after the attack part. And decay controls how long it takes to get there. So just for show, like let me put the sustain pretty low here. Let me bring that back down, and then if I have like a short decay, you see it like, yeah, that's maybe a little too short, but yeah, as you can see, or maybe if I go like this, so it goes there, then yeah, really fast decay gets to the sustain point really fast. If I bring that up much higher, then see now it's like fading out a lot slower. And then yeah, the higher the sustain, the less it actually ends up decaying. And then once it hits the sustain level, yep, then it just stops decaying. And then there's also this decay 2, which actually controls, it's basically a secondary decay after it hits the sustain. So what you can end up doing is you set this decay kind of like here. Let's bring the sustain a little bit back up, and then give it a much like slower decay 2. And let's bring this back like that. So once it hits that sustain level, it now uses the decay 2 rate. So it's much slower, since I've set it like much less here. And then at some point it'll just decay all the way to 0, right? And then release here, if you've noticed, if I put these back, if I let go of the key, it just like instantly stops, right? And so what release does is it'll control, basically, it's kind of like decay 2, but like it triggers when you let go of the key. So if I have it at like 3 here, oh, I forgot. Yeah, it actually oh yeah, I guess it just happens, but like if you let go. Oh wait, oh, sorry, I had the wrong parameter set, but if I put this to like 5, right? So this is like, it'll just go to max, so long as I'm holding down the key, it stays at this level, and then once I let go, it starts fading out. So that's basically, the release is controlling like the fade out. So that's kind of the basics of the operator. Oh, RS is envelope scale. This you don't have to worry about. I'm not going to go into it too much detail, and if you're curious, you can play around with it. But it basically controls like some of the rates as you play the higher keys. It's supposed to like model actual instruments, but I don't know. It's kind of hard to explain, I guess. And then there's multiplier, which basically scales the frequency or the key that you're playing. So like if I'm just playing like C here, or let me set this back to, oops, I keep dragging this. I'll set that back to like just normal, right? So this controls like it's a multiplier in terms of the frequency that you're pressing, of the key that you're pressing. So if right now it's 0, that's like half frequency. If you have 1, you can see it went an octave up. 2, it's another octave up. 3, it's like 1.5. 4 is 2, and then let me actually turn that down. And actually, let me start back from oops, that's too much. That's see, that's 0, 1. That's like times 2, or I guess this is 1/2. This is 1. That's 2. 2.5 or something. I don't remember. You can look it up. And then it just goes up and up, right? And then DT here is detune, which it's as the name implies, it detunes the frequency of the keys just a little bit. But this particularly is important for when you combine operators, which I'm going to tune in amplitude modulation. It's controlled here in LFO amp. So basically, it goes this little like tremolo effect. And SSG EG is some chip specific thing I won't get into. But yeah, so let's start pulling in some of the other operators, which is where really the fun begins with FM synthesis. So FM being frequency modulation. Means that you have these operators. If you see up here, you kind of have these operators chained together. And so operator 3 kind of has like the same mode of operation, right? It's a sine wave, plays a sine wave. But in this arrangement here, the output of operator 3, that sine wave that you've programmed in, will modulate it's basically an input to this operator 4, and it'll just basically distort the sound. And so if we have this sine wave on op 4, right? And then as I start bringing up op 3, you see it like starts changing the shape of the wave as I bring the level up. And then that's like all the way here. It's like super distorted. It's got this like weird shape. And then going back to the multipliers, this will kind of change. This is kind of how you'd like it. I don't know how exactly the best way to describe it, but as you can see, it's the way that it's changing the shape of the wave, or the sound of the wave, is different. So like at multiplier 0, and what's really important is like the ratio of these. So this is 0, this is 0, so it's like the same multiplier. So like at this level, it has like this shape here. If I go 1, it has more of this like square wave shape, because this is twice the frequency, or the modulating frequency is twice the frequency of the, I believe this is called the carrier operator. So you have the carrier and the modulator. Carrier is just basically the thing that you end up hearing, like the actual outputs, and then the modulator is the operator that's modulating whatever carrier, or so yeah, you can like control how much this operator modulates, or how much op 3 modulates op 4. You can control like the multiplier here, and I can see like as you go up, it gets like a lot more. I don't know. The modulation just it uses higher frequency modulation. It's a little hard to explain how exactly it works, which is why I encourage you to actually just like go out and play with it yourself, and then you get like a sense of how it actually works. But yeah, going back to the ratio thing, is like like if I play like this bass octave at multiplier 1, right? It has like this shape. It's actually very hard to like properly capture. I think if I play F, it's still kind of iffy, but anyway. Yeah, I've got like this little shape. Actually, if I play an octave higher, and then I like go to 2, so it's octave higher, but then I play an octave lower, it's the same. So that's why what really matters is the ratio of these multipliers. But you could do like 2 and 3. And you get like these sort of gnarlier, as you get into like non integer ratios, I guess, like 2 and 7. You get these like more atonal modulations, I guess. And then if you like really crank it up, it gets super distorted. But let's put these at like 1 and 1. So we now have like this wave. And if we go back to what I was explaining with ADSR, this actually lets you control the amount of modulation over time. So, I'm gonna bring this up, like let's say a space level of like 11. It's very distorted, right? It looks very different from our original sine wave. But then we can play with these parameters a bit. So let's say I want this to go down like a little bit, and then Give it a bit of a decay here. And then, I don't know, give it another like D2. And now if I press the key, you see the amount of modulation shifts as time goes on based off of the envelope that I like all these parameters that I've put here. And then so then these algorithms, which basically they change the arrangement of the modulation. So you can just like chain these things over and over again. With this chip, you have 4 of these operators. So there's different arrangements of those 4 operators. So you have like, say this one currently is algorithm 0 is just all of them in a row. So, you know, you could say like, I want to do another one here. Give this maybe like a slower attack, and then maybe just a slower attack, right? So if actually maybe that's not the best demonstration with this algorithm, but you know, like if I just go like this, this actually probably the TL was too low, but now we get more interesting sounds, right? And then I could even like increase the attack so it fades in. So see how that has like a kind of interesting sound as like the key progresses, where like you have this one and you can click here to mute the operator. So like with just these two, it's like, so it gets very modulated at the beginning and then it kind of fades out as the key goes on. And then if I put this one, operator 2 on, which has this fade in. So this operator 3 has its like kind of fade out, but at the same time, operator 2 is fading in, and so it also is at a different multiplier, so it has like different harmonics or distortion or whatever. And so you can hear that it kind of the modulation on this operator just like comes in. It doesn't it like just sounds like this one. Like I don't know how else to explain it other than just like play around with it, right? And then you have operator 1 all the way at the back here, which is, so it's basically going to go like operator 1 goes and modulates operator 2, and then the output of that modulates operator 3, and that modulates operator 4, and then the result of that is what you end up hearing. So I could even just go like all the way up to 11, bring this up here. You can see that like because of how these operators are chained, you actually don't hear the effect of operator 1 until operator 2 is like fading it in. And that's when you hear this like 11 multiplier extra like ringiness on this op 1. See, that's like all these like gnarly little folds in the wave in the yeah, in the skill soap. So yeah, that's kind of how FM synthesis works, I guess. And let's see what other, feedback. Feedback is probably, let me go to this one and disable these just so I can have just the raw output of the operator that gets the feedback. But basically feedback means the operator actually, as the name implies, feeds back into itself, and so it actually ends up modulating itself. And so this kind of does a bunch of weird things. I don't really have like a good way of explaining it, but again, encourage you to just play around with it. So right now it's 0 feedback, right? So it's just, right now it's just a basic sine wave. If I bring this to 1 feedback, so just basically it goes up to 7, but the higher it is, the more feedback gets applied. Right now it still looks pretty much the same, but you can maybe kind of see like this sine wave is a little bit folded like more to the left. And then if I as I increase it, the effect of the feedback gets more dramatic. And then here, you can see like, it actually kind of looks a little bit more like a sawtooth wave, where like this is a lot more steep on the rising edge, and then the falling edge here is more gradual. Here it's like really like, this almost really looks like a sawtooth wave, right? And then as you go like 5, this is like really distorting the wave. And here it's like almost basically noise. There's like a little bit of distinction of like the original wave, and then like at 7 it's like basically noise. So that's one way that you can get get noise out of FM synthesis. You just crank up this feedback, and then you can also like increase the multiplier here, right? It basically sounds like noise. You hear a little bit of the original like carrier wave, but it's the actual noise just kind of overpowers most of it. But another interesting thing is like, if we go back to the whole ADR SAR thing, like let's give it a sustain and decay here, and yeah, let's do like 5 feedback. Oops, let's put that back down to 1. So what's interesting is as the output level of the operator goes down, so does the modulation that it feeds back into itself. So like if you have this like 7, it's noise, and then as it comes down here, it's like back to normal. So yeah, that's just kind of one of the effects that you can do with feedback. And then yeah, algorithm. I'll touch on this a bit, but I'll get into more detail about these different algorithms. But as I mentioned, it's kind of changing. You have these preset arrangements of which operators are modulating what, and what operators come out. So this one that I was using just now, algorithm 7, just puts them all in like parallel. So what that ends up being is you just have a bunch of independent, let me re-enable all of these. You just have a bunch of independent outputs. So you put this one at like 1, put this one at 2, or actually, you just go 1 by 1. So that's 1 operator, 2 operators. This is just 2 octaves basically. Actually, it's just like 2 octaves being played at the same time. You can put in this one. So there's actually no modulation going on right now. It's just a combination of sine waves with this algorithm. That one here. Let me turn these down so it doesn't clip. So yeah, it's just a combination of sine waves. Oh, and then the detune. I actually didn't demonstrate this yet, but what you can do, actually, just for demonstration purposes, set these all back to the same multiplier, but give them different detunes. Actually, let's just do these 2, right? So interesting is you can actually get this like weird effect. I mean, maybe this isn't the best algorithm to demonstrate, but if we go like this, and bring that down, so what we can do is like, what you can do is with the detune, you actually get this like, depending on like the difference in detune values, you get like this kind of chorusy effect where, because the frequencies are a little bit offset, it's like kind of weird folding pattern, I guess. And then if I go to like -3, you can see this phasing effect or whatever is a lot faster than if they're like 0 and -1. So that's how detune works. I guess another fun thing is like you can just turn on the amplitude and it just does this fun thing. But yeah, that's basically all those parameters, and you have these different arrangements of like which operators are modulating what. I mean, I guess I can just go through them real quick. So as I mentioned earlier, algorithm 0 just has them all in a chain, so it's like one wave or one operator that's modulated by another operator, and all the way up to from 4 to 1. Here, what ends up happening is you have operator 4, which is modulated operator 3, and then operator 3 actually gets modulated by both operator 1 and 2, but independently. So that's what like this sort of branching thing indicates, is that like the operator 1 and 2 are independently modulating operator 3, and then the output of that modulates operator 4. And then algorithm 2, you have this chain here with operators 2 and 3 modulating operator 4, and then also operator 1 modulating operator 4. Here, kind of similar, but it's operators 1 and 2. There's this 1 to 2 to 4 chain, and then 3 to 4. The difference between these two is that here you see this operator 1 that has feedback. It's just this 2 operator chain here, whereas here the operator with the feedback has this 3 operator chain. And then operator 4 or algorithm 4, you basically, this is like two operator configuration. So both 2 and 4 have outputs here. So if I turn these two off, here we've got two waves. And actually, going back to the chorus thing, what you can do, one of the things you can do is, if you're using algorithm 4, is you basically set these two sets of operators the same, but then on one set you change the detune. So let's see. So all these, yeah. So let's bring those up to 10. So these are like 0 and -2. So it kind of already has this. Or actually, let me put this to 1. And then let's just add like a little bit of modulation here to both of these. Let's make them the same. So let's put like both of these to 22. And see, you have this like sort of phasey effect, like kind of like a phaser effect, or a chorus effect. But yeah, it's just kind of. So this is interesting to actually see like the phase effect happening. Where basically what's happening is like if you look at a sine wave, you basically have like some of these peaks and troughs. Or like the top peak and the bottom peak, it like adds together, but then with the detune, where it actually ends up interference with the wave, just shifts as time goes. So you go like that. It's so harder to see at this like slower rate, but once you have everything together, you can see that it like this peak kind of moves over. But anyway, so that's algorithm 4. Algorithm 5 is these 3 operators in parallel, and all of them are modulated by the first operator. And again, I'll go into further detail, further demonstration later. Algorithm 6 is the same, but the first operator only modulates one of these. This operator 2, and then yeah, algorithm 7 is just all of them are just in. It's just like 4 operators, 1 key, 4 operators. That's it. No modulation, except for the feedback on operator 1. So yeah, that's kind of the basics of all these like FM synthesis parameters, all the operators, envelopes. It's just all, a bunch of sine waves. You can set the multipliers and the levels, and then you can set the envelopes to control how the sound gets modulated as the key kind of goes on. Yeah, that's kind of the basics. So now I'll get into some presets that I have here. These presets came with Furnace in the example instruments. And I've picked out an interesting example, one for each algorithm. And I'm just going to try to deconstruct the parameters that you see here in each of these instruments. So here you've got this acoustic bass. It's using algorithm 0, so all these operators are just kind of in a row. So if you wanted to try to deconstruct how whoever made this instrument might have arrived at these parameters, what you can do is you start with operator 4. So you just mute all of these other modulating operators. That's really low. Yeah, so operator 4 is just a sine wave. It's got instant attack, no decay, sustain, whatever. And then a release over here. It's also got some detune, 0 multiplier, max level. And then if we go up the chain, we now have operator 3. So now we have this one modulator. I don't know if we play it. So it's got this envelope. It decays. It's got 12 decay, 2 sustain. So it doesn't go down that much, but then it's got decay 2 and a release. And the level's like 24 here. And then it also has like this interesting detune arrangement where this is -3 and then this is +3. So it's like, kind of as far as it can go. Actually, technically it's a 4, but And so this gives us like little phasey effect. But then at some point, the modulator hits 0 and now it's back to a sine wave. And then if we turn on operator 2, we've got basically no envelope, I think. Yeah, it's basically no envelope, and it's got kind of a low level. But the multiplier here is 4. So it gives a kind of ringiness to the modulation because of like the ratio from 0 to 4. And but because it's chained to this operator 3, which fades out, the ringiness also fades out over time. So you can see some of the like higher frequency ringiness in the modulator at the beginning, like this stuff, fades out as operator 3 fades out. And then operator 1, it's got multiplier 6. It's got a bunch of decay over here. So this ends up giving a like a much shorter, higher ring, but it fades out earlier. Like if you compare without operator 1, it sounds a little bit more normal, but then with operator 1, it's got that little like twang at the beginning, but it's just a very momentary twang. And then with so that's kind of how all these operators are laid out. And then you can also like just play around with these presets, right? So like what happens if I change the multiplier here? It gets less twangy. Or if I increase it, it gets really twangy. Or ringy, or whatever, whatever adjective you want to use. Or if I even like increase these, really increase the twanginess, that initial twanginess. Or I can change like the level of them, so that's like almost too much twanginess here at this max level. But if we bring it back down to like, so you can just like fiddle with these knobs. Play around with it, see how you can like kind of change the shape of the sound to what you want, or like let's say I want a little more twanginess, right? I can decrease or I guess increase. or I want like more. Yeah, you can just like play with these, all these parameters. So that's Acoustic Bass 2. We've got Harmonium, which sounds like this. Kind of sounds like a square wave, or looks like a square wave. But again, if we deconstruct this, we've got this bass note. It's just a sine wave. We have this one operator 3 modulating it. It's kind of like the bass square wave, and again, for this effect, you have like this 1:2 ratio between these modulators, or sorry, not modulators, multipliers. Sorry, they both use the same letters. And then you now have two different independent modulators for this operator 3. You have operator 2. So as you can see, like operator 2 kind of is set to, and also all of these have kind of no envelope, they're just flat. But because of the detune here, that's what's giving it this like phasey effect. And then you include operator 1. Everyone kind of gives it like a little bit of harder edge, and as you can see, the feedback's maxed out here. It's got TL36. If we do just operator 1, now it looks like a square wave. Created a square wave with FM synthesis. But yeah, so operator 2 gives it this chorus effect. Operator 1 just kind of shapes it into more of a square wave. And also, if you like reduce this feedback, you get less of that like squarey shape. Yeah. Now with electric jazz guitar, sounds like this. It's got a bit of a softer shape, but again, same exercise. We've got this envelope that just kind of fades out on the bass operator, and then operator 3. So there's actually two tracks, like, or two modulator chains here. There's 2 and 3, 4, and then this 1, 4. So that's the 2, 3, 4, and then with 1. So you can see like one, based off this envelope shape, it's kind of just giving it a kind of pluck sound. So it has just a very plucky sound effect right when you hit the key, but then like, you know, very quickly just gets out of the way with this fast decay, like, yeah. So 21. So yeah, very fast plucking effect. And then 2 and 3 here are just shaping. It just kind of shapes this this wave. So 1, 1, 4. We have a little bit of phasing effect with these two detunes being 0, and then this one being -1. And then these envelopes are basically flat. They have a little bit of release, but yeah, they're mostly flat. So altogether, got kind of a sort of a guitar sound with this operator 1. Like here's the bass sound, and then that pluck. So now for this next example, byte organ with algorithm 3. It's very similar to this one, but again, the chain 1, 2, 4, so it's like 3 operators. Then this one has the feedback on it, although this instrument doesn't use it, as you can see here. And then this 3 is just, you know, there. So we've got a flat envelope as our bass carrier operator. With operator 3. And, So like very slowly fades up with this D2. And it also has a little bit of phasing with these detunes. And then if we look at the other chain, 1, 2, 4. Well, let's just start with 2, 4. Okay, so yeah, so 3 is 1.5 or something, I think. And so 0 to 3 kind of gives it a different harmonic stuff. Hopefully you know what harmonics and acoustics, whatever. I don't really know. I'm just kind of rambling. But yeah, and then operator 1. As you can see, this one actually has the amplitude modulation here, so it gives there's a little bit of like I guess wobbling. I can see it kind of wobbles, and then like just for effect, crank that up to all the way to 3. You can see it's a lot more exaggerated, but let's put that back to 1. But you also see that like because of this short decay at 19 and small little sustain at 2, there's a little slight like pluck effect on this instrument too. Turn that to 0. And then like also change this down to kind of compensate. I've kind of gotten rid of the plucky sound, but if I bring that back up and then yeah, that plucky sound is back. Yeah, if I put operator 3 back in, brought in this the phasing effect again with this detuning. But as you can see, it fades out and it eventually kind of stabilizes to this sound. Yeah, so that's algorithm 3. For this algorithm, for example, I've got a piano instrument. Sounds like this. And so with algorithm 4, as I mentioned before, this you've actually got, it's actually kind of just like two operator instruments combined. So like that's one, and then here's the other one. And then you combine them together, it sounds like this. But another thing that you can kind of see here is that these two operators are set to 3 detune, and these two are set to -3. And so that's what kind of gives that maximal phasing effect here. But yeah, so you can kind of go one by one. You see that by the D2 and D here in the sustain, kind of sounds like a piano key, sort of like in terms of, you know, when you hit the key, it's got a sharper like attack, and then it just kind of fades out. And then this has yeah, so these are 1-to-1, these are also 1-to-1. But these also have like a fade out. If you look at the other one, this is much shorter, so if you combine them, I guess you had that thing. Yeah, and then 6 feedback, so it has that like sort of sharpness at the beginning, and then it kind of peters out, and all together, got that sound. This one, C64 wave combo, is actually a funky one. It sounds like this. It's a very noisy wave. I think this is actually referring to one of the C64 combined waveform things. Anyway, it's just a fun little detail, but yeah, this one's using algorithm 5, so it's actually these 3 sounds that are all modulated by this operator 1. So you've got so it's actually the 3 like octaves, right? 0, 1, and 2. All together, it sounds like this. Pretty straightforward stuff, and it has a pretty flat envelope. These have like a little bit of a like attack decay thing here. And then you enable operator 1, you get like the majority of the modulation here, which is, but yeah, you can hear like basically these all three of these operators without any modulation, and then just go like that, and yeah. And what you could also do is you just do like these 1-4, 1-3, 1-2 paths, and they're kind of just adding together. So you can see like this one has the I keep wanting to say modulator. This one has the multiplier all the way up to 10, and level at like 20. So it just like adds a ton of ringiness. It also has a ton of feedback here. So if I like turn that feedback off. So it's just there to kind of like add a ton of like grittiness to the sound, I guess. But yeah, you have like 1-4, 1-3, and 1-2, and then you put them all together. You get this like fun little sound. But you kind of see like sort of the majority of it is like this little wave shape, and then you just have operator 1 to kind of like create a bunch of these like harsh little, I don't know, creases or whatever. So now this next example is a triangle. Looks like a triangle wave. But here it's got in algorithm 6, 2, 3, 4. 3 and 4 are just the pure sine waves. But this top one has like 1-2 operator chain here. So again, if we just go operator by operator, so actually just actually both of these have this like fade in, and all these are actually 2 multiplier. So I guess really all that's really happening here is that you've got I guess this is just kind of fill in the body of the wave, and then you have this like 2-1, which just adds a little bit of detail, I guess. So all together it looks like that. And then this last one, Saw-Sine pad, used in algorithm 7, which is just these 4 operators, all just going independently. But it sounds like this. But the interesting thing is that because operator 1 still has its feedback, there is still actually some modulation. So it's not just 4 sine waves. You can have this operator 1 sound less like a sine wave, and I don't know, make it sound more interesting than just a sine wave by adjusting the feedback. So operator by operator. And then, yep, that's like this operator 1. That's the sine wave. Or sorry, not the sawtooth. And then these like 1, 2, 3 gives it this 1, 2, 3 multiplier arrangement gives it like basically more notes in the pad. So yeah, that's a deconstruction of some each algorithm or example instruments in each algorithm. And so now the fun part is let's try to just make instruments from scratch. So, say you want to go outside the box and you have an idea for a sound that you want to just build from the ground up. Or you have some samples, which I've prepared some samples here, and I'm using OpenMPT here. Also a free tracker tool, but it's more sample based. But in particular, I'm just using it for its sample editor and viewer here. I've imported some samples here. But here I've just got a flute. So it's a pretty soft sound, but you can see I'm just going to be switching between Furnace and OpenT here, but you can see that like it kind of has this attack here, and then it kind of fades out, but it also maybe has some a little bit of maybe some amplitude modulation, where it gives a little bit of like a tremolo effect. So if we go back to Furnace and let's just call this like Flute. So we want to start off with all of these operators basically muted at 127 here, and then we want to like just start with let's start at the end and then kind of work backwards in terms of the modulation. So we'll just bring up the level up. Well, maybe just start with like this multiplier. We'll add. Yeah, we'll bring the attack up here, so it kind of has that like short but noticeable fade in to the sound, and then so basically like this fade in here, and then we want to like fade it back down here. Now I can't like completely model like the shape of this sample, but we can try our best. So maybe we'll give it like a little bit of decay. So we turn down the sustain, maybe like 2, and then have this decay down here. Could probably use a faster decay, but maybe less sustain. So yeah, I mean, like that seems pretty close to what we have here. And it's like, so if we look at the sample again, like if you zoom in and you kind of look closely at the waveform, it already looks pretty close to a sine wave. You can kind of tell it's like not quite a perfect sound wave, but it's pretty close. And like with the single operator, we're already like kind of close to the sound, right? It already like kind of sounds like it. We can probably apply a little bit of modulation. So let's go ahead and try to do that. So maybe we bring this up a little bit. So you can see as we increase the level here, like we don't want it too high because that just creates a completely different sound from what we want. We still want it to sound kind of close to that sine wave. But yeah, you can see like in this like 46, 40 range. 40 is probably maybe too much, but probably like 44 maybe looks pretty close, right? If we look at this wave here and we compare it to like over here, like you can see there's like a little bit of this fold here. So it's like, it's like pretty close. And then if we go back here and we kind of look at like the beginning to kind of think about extra like waveform shaping that we can do. Maybe there's like let's not do that, but like here you can see this kind of more. Maybe we can apply more modulation right at the beginning of the sound. So if we go back to Furnace here, maybe we'll do something like, I don't know, we'll just do something like this. So we have this kind of bass sound, maybe even, I think 12 is nice. So yeah, we have like 2 operators that we've set, and it already sounds pretty close to that flute sound. But say we want to do, or we want to add like a little bit extra modulation at this beginning here, right? So maybe we just add another another modulation operator here. And what we want here is we probably want like bring that sustain all the way down. Probably get this pretty fast decay. 17. Let's just try 17 for now. And probably same like 1-to-1 ratio. Maybe 2. And I have this at 0 just for exaggerated effect, but I mean that also will help us like hear how the envelope sounds. And so like right now it's like maybe still too the decay is a little bit too slow, so if we bring that down like maybe too much. So 18 I think is where you can really hear it. 19 maybe, but like 18 decay here, and then I don't know. I'll probably just do this and yeah, and then like probably want to set some release here too. So I think if we put 0 release, it basically stays at whatever the pre-release level is. Like it basically doesn't fade out when you let go of the key. Yeah, 8 release sounds pretty good. Like it sounds pretty natural. It's not like super cut off with like 15. It just hard cuts. If you have it at 8, it just kind of fades out naturally. So yeah, it's not bad, I would say. Maybe we want to cut that off too. Yeah, well, that's like a flute sound. Let's say that sounds like a flute. All right, so next instrument we've got like a bass, acoustic bass. It's a little bit quiet, but that's fine. So actually, let me go back here. So here, there's a few things to know about this instrument. One is it's got like a little bit of an attack, but like pretty fast, and then it decays quite a bit. And then you can also see like over here, there's like very much not a sine wave. It's got like this fun little bend here. But it also got like this, it's a lot more exaggerated over here. And then even here, there's like quite a bit of like a noise, like a little pluck sound here. So we'll go back to furnace here. And we try to recreate this. So again, we've got all of our instruments, or all of our operators muted. We'll bring this up to... and since it's a bass, we probably can start with set 0 just so that we get like the low frequencies. But yeah, I got like a little bit of attack there. And this should like go down like that, maybe. It's the case, probably. It could be a lot faster. Yeah, that's us. A bit of decay here. That's like pretty decent. I think that's pretty close to what we have here. And so now let's try to get like this little shape here. So back here, we'll bring this up. I want this 1-to-1 maybe. Yeah. So here you can already start seeing like this little well, we just need to bring that up enough. Yeah, so this kind of gets, it's kind of there. It's not quite as close as we wanted, so maybe we have another we just play with these parameters. I still want this like 1-to-1. Let's actually use one of these different algorithms so that we can try to make use of that feedback thing. You want this. If we try. Okay, so it's not quite as close to like what we originally had here, but I don't know, it still sounds pretty similar, right? Kind of. So I don't know, I'll call it good enough. And then going back to this thing where it's got like a lot more I don't know, it's not as smooth over here as at the beginning here. We can bring in operator 2, which has well, let's bring that up. We do like 1, and let's make sure, yeah, we go like that. Just gonna keep playing with these sliders. So let's, let's there's a bass sound. Not too happy about it, but it'll do just for the sake of the tutorial, I guess, or just the example. Cool. Let's try yet another instrument. Got a pizzicato string here. And I chose this one because it has kind of an interesting envelope here. It's got a very loud like initial pluck here, and then there's got like a little bit of this like fade in here. So so I was thinking, like, how would I model that in an FM instrument? So I might want to use like, one of these algorithms here, like maybe 5, so we can have like 2 separate so we're gonna try to have like 2 separate carriers here. So we have like this one, the initial, let's try to do like the initial pluck. Oh, oops, sorry, I was didn't have it on my furnace window. But yeah, as I was saying, let's try to do algorithm 5. So we have these 3 independent operators to play with. So let's first try to model that initial pluck. We'll do something like this. Or even sharper. Too sharp. So is that pluck? Let's start bringing in another operator. And you know what? Yeah, let's give it a little bit of detune too. Turn this one down a little bit. Alright, turn this one up. And then, yeah, let's maybe like have another detuned operator here. Let's bring this up. Actually, this release doesn't really matter because we're all, these are all going. Actually, maybe it does. Yeah. Well. And then maybe this one just kind of has like a normal strings. Yeah. Multiplier 0, so it has a little bit more like body, a little bit more bass. Then we introduce operator 1. That maybe we get some of this like, Foley effect. I think also of note is like you see how it's like I have a lot more. I don't know how to describe this. Like, yeah, it just like has more of this Foley effect. So. Is 7, so it's like the ratios. But maybe. So maybe we don't need all 3 operators. Maybe we can do. No, I think that's fine. I think there's still too much sustain on one of these. I think it's this one. This one was, yeah. too much ringiness. Bring that back to 2. Yeah, so that's actually. I don't know, something like that. The thing is, like, I think with strings, strings typically have like a lot more complex sound. So it tends to be kind of hard to capture them in FM from what I found. But anyway, speaking of, the next sound we have is strings. But typically, strings have like there's like multiple strings, right? And they all kind of have like this chorusy effect, which tends to be kind of hard to do in FM, but we can try anyway. So going back, it might be good to have like use this 4 algorithms so that we can do this fun trick where we have these two kind of going independently. So yeah, bring that to like 16. Looking back at this, it's got this sort of attack here, like it fades in, and it just kind of is flat towards. So, oops, got the wrong window. Yeah, so I think that's like, yeah, and then we'll just put like, yeah. So that kind of sounds like the string that, like the envelope of the string that we want. Let's set the same parameters here. Then, maybe like, doesn't have to be exactly the same. And then let's just do some modulation here. Well, let's put these multipliers to 1. Those release to 0 so it doesn't fade out. Put these to like 3 and -3 or something, so that it's extra phasiness. I think that actually kind of matches like the characteristic that we want of the sound. It's like, again, there's like a lot of complicated harmonics and stuff with string instruments. Like this, like just kind of is all over the place. But yeah, I'm gonna try to. I mean, I think that's like not bad, and then we just similarly apply the same settings here. I can just right click to type in the values there. Maybe too much phasing. Let's bring those back. really want 0, but maybe like 3 or 4 sounds. It doesn't quite sound as stringy as I want it. I think, like, let me listen to this sound. Yeah, see, it's a little hard because it's like very, like, at least this sample in particular is like very chorusy, but. Maybe this is too much chorus. Yeah, it's still like pretty ringy, I would say, or like it's hard to describe, but if we focus back on, I think this needs to just sound more. Let me just do 101. No, it sounds a lot more patty. Kind of like this. It sounds a little bit more like a string with this like 2-3 ratio, right? And if we bring these all back together, it's kind of there. Like sort of, right? Yeah, it's kind of there. You know what? I'll call it. I'll call it a success. All right, and then let's do one last example here. We've got a distorted guitar. So this is where we're really gonna pump up the modulation on the instrument. Might even just have like, yeah, might just use algorithm 0 just to all be in a row. So this instrument, I think, yeah, we'll do 1 multiplier for the bass sound or the bass operator. With a little bit of attack, but we'll want a pretty fast decay here. Maybe too much. Yeah, so it's probably good. And then we start looking at the waveform. And so what I notice is, one, there's like a ton of noise here, so it's like a little bit like you hear at the beginning there's like a little chug, and then so we'll probably want that in one of the operators, like basically fast attack or just like fast decay, and then it just like kind of fades out at the end. And there's probably like some detune stuff we can do to get like this sort of phasey effects. There's a lot of like harmonics, right? At least like smaller waves here. The smaller but like faster waves, basically. But I would say there's an exact science, which again is why I encourage you to just play around with all these sliders and stuff. But yeah, So, I mean, without further ado, let's just like mess around, right? So let's try. Yeah. And then maybe we just do like okay, so that's like good amount of distortion there. I actually like the non integer, like 1 to 3, because 3 is like 1 point times 1.5 as a multiplier or something. So like this is pretty nice. Like this is already. We already got a bit of that sound, right? So we'll just keep dialing it in with these other operators here. Like, this is already sounding pretty nice. Oh, probably. Actually, less phasing like that. Then, ooh, actually, that's nice. That's a lot of distortion. That's nice. So we'll crank it up and then add some of this sustained decay stuff. Might even throw that on a separate, like this. No. Actually, let's keep it at this. There we go. Let's get even more chugginess on here. Let's go like 11 there. Ooh. I don't know about you, but I already like that. Hell yeah. Alright. I don't know. I think I was gonna, do this thing. But yeah, I mean, I don't know. I think that's pretty good myself. Alright, yeah. So there's our 5 instruments: the flute, the bass, string. This one's kind of weak, but yeah, whatever. Strings. And then the guitar. Yeah. That's what I've got. There's the that's the FM crash course. Hopefully this either gives you some extra clarity on how FM synthesis works, or maybe I don't know, maybe it inspires you to go play around with some instruments, go make some on your own, just play around with the sounds. But yeah, hopefully you found this useful. And I don't know, go have fun.